Your task for today is to complete the following 20 question grid. This is very similar to the grids that you've completed previously, but it has a new set of questions for you to practice. Because of this, I strongly recommend you watch the explanations for each type of questions before attempting it. These will appear at the end of the video. There are also video links embedded within the Show My Homework task with further help on each of the topics that are covered. You can either print the worksheet out and write the answers directly onto the grid, or do the work into your maths book or a separate piece of paper. Either way, make sure that you show all of your working out and refrain from using a calculator to answer any of the questions. Once you've completed the grid, make sure you mark your work accurately, put your score, and try to correct any of the mistakes that you've made. When you've done this, take a photo of your work and upload it to Show My Homework so I can see how you've got on. In this next part of the video, I'm going to explain how to answer each type of question that appears in the grid. The first type of question will always ask you to add or subtract two fractions. In order to do this, we want to make a common denominator. Now I'm going to show you how to do this using the smiling kiss method. For our first question, which is 4/9 added to a quarter, we can start off by adding our smile. That's 9 times by 4, which determines what goes on the denominator of our fraction. Next, I want to add my kiss by cross multiplying. So I get 4 times 4, which is 16, and because we're adding, I'm going to plus 9 times 1, which is 9. That's where the kiss part comes from. So I know that my answer is equal to 16 plus 9 over 36, and all I need to do now is simplify it. 16 add 9 is 25, so my answer is 25 over 36. What I should always do is check to see if I can simplify my answer. In this particular case, I can't. Doing the same thing for the second example, which is 3/4 minus 2/5, I add my smile, which means I'm going to have 20 as my denominator, and on the top I have 3 times 5, which is 15, take away 4 times 2, which is 8. I know that 15 take away 8 is 7, therefore my answer is 7/20. As with the previous example, I should always check to see if I can simplify my answers. In this particular case, I can't. The second type of question will always ask you to find the value of an expression after a substitution. My first example says that if a equals 2, what is the value of 7a plus 6? Well, 7a means 7 times by a, and because a is equal to 2, I can say that that's 7 times by 2. I then need to add 6 onto the end. I can use BODMAS to work this out, so 7 times 2 is 14, add 6, gives me a final answer of 20. In my second example, it says if b equals 4, what is the value of 20 minus 3b? So this would mean 20 minus 3 lots of whatever b is, which is 4. Again, using my order of operations, I know that I need to do 3 times 4 first, and that's 12, so I get 20, take away 12, and that gives me an answer of 8. In my third example, it says if c equals 6, what is the value of c squared minus 5? C squared would mean 6 squared in this particular case, and then I need to subtract 5 away. And again, using my order of operations, I know that 6 squared is 36, and if I subtract 5 from that, I get a final answer of 31. The third type of question will always ask you to evaluate an answer. To do this, we need to work out the exact answer of the calculation. So first of all, I know that 2 cubed would be 8, and I want to times that by 5 squared, which is 25. I now need to work out what this answer is. If I'm unsure, I can use a grid multiplication, but counting up in 25s, I know that I get to an answer of 200. So that would be evaluating the question that's been given. For the second example, I need to work out what 2 squared is. That's 4. Times it by 3. And then times that by 10 cubed. That's going to be 1000. So doing this in stages, I know that 4 times 3 is 12. And then I need to times this answer by 1000. So my final answer would be 12,000. The fourth type of question will always ask you to solve an equation. Sometimes it might have brackets in. In both of my examples, I'm asked to find the missing value y. To do this, I need to rearrange both equations and get y by itself onto one side. In my first example, I'm asked to solve 3y plus 8 equals 2. The first thing I'm going to do is take 8 from both sides of my equation. Doing this would leave me 3y on the left side, and on the right 2 minus 8 would give me minus 6. Next, because I've got the y's on their own, I want to find out what 1y is, so I can do this by dividing both sides by 3. Again, on the left, 3y divided by 3 leaves me with 1y, and minus 6 divided by 3 equals minus 2, which means my final answer is y equals minus 2. In my second example, I want to do the same thing, however this time I've got a bracket. So firstly, I want to expand this. Because there's a 5 on the outside, I need to multiply this by everything inside my bracket. So expanding the bracket would give me 15y, that's 5 times 3y, minus 5 times 2, which is 10. That would equal 20. The next thing I need to do is to get my y's onto one side like I did in the previous example. So I'm going to split it down my equal side, I'm going to add 10 to both sides, and this gives me 15y on the left being equal to 20 add 10, which is 30 on the right. Again, to get y by itself, I want to divide both sides by 15. So on the left I get 1y, and on the right 30 divided by 15 equals 2. So my final answer is y is equal to 2. The fifth type of question will always ask you to do a metric conversion. You'll be asked to put either a less than, equals to, or greater than sign to compare two values that have been given. There are 3 types of metric conversions that we're going to look at. The first one is distance, then weight, and capacity. For our metric conversions of length, there are 3 main things that you need to know. Firstly, that 1 centimetre is equal to 10 millimetres. Also, that 1 metre is equal to 100 centimetres. And lastly, 1 kilometre is equal to 1,000 metres. We can use these to help us change our values into an equivalent unit and therefore compare our answers. In my first example, I can use my first fact, that is 1 centimetre being equal to 10 millimetres, to convert 5.2 centimetres into millimetres. So therefore I need to times by 10, because 1 centimetre is 10 millimetres. 5.2 times by 10 gives me 52 millimetres. And now, because the units are the same, I can compare my two answers. I know that 52 is more than 43, so therefore I can say 43 millimetres is less than 52 millimetres, or 5.2 centimetres. In my second example, I can use the fact that 1 kilometre is equal to 1,000 metres to convert 3.7 kilometres into metres. I can do this by timesing by 1,000. That's because 1 kilometre is 1,000 metres. So 3.7 times 1,000 would give me 3,700 metres. And again, because the units are the same, I can now compare them. I know that 3,700 is more than 3,500, so I can say 3.7 kilometres or 3,700 metres is greater than 3,500 metres. The second type of metric conversion is weight, and there are 2 things that you need to know. The first one is that 1 kilogram is equal to 1,000 grams, and secondly, 1 ton is equal to 1,000 kilograms. Again, we can use these conversions to help us compare two values given with different units. In my first example, I can use the fact that 1 kilogram is equal to 1,000 grams to times 5.9 kilograms by 1,000 to turn it into grams. 5.9 times 1,000 would give me 5,900 grams. And comparing that with the initial amount, which is 7,800, I can say that 7,800 grams is greater than 5.9 kilograms or 5,900 grams. In my second example, I can say that 1.9 tons is the same as 1,900 kilograms. I can get there by timesing my answer by 1,000, and that's because 1 ton is equal to 1,000 kilograms. Again, comparing this with the 2,100 kilograms at the start, I can say that 2,100 kilograms is greater than 1,900 kilograms or 1.9 tons. The final metric conversion is to do with capacity. You need to know that 1 litre is the same as 1,000 millilitres. Looking at my first example, I can therefore say that 3.4 litres by timesing it by 1,000 gives me 3,400 millilitres. I know that 3,400 is less than 3,450, so I can say 3.4 litres is less than 3,450 millilitres. In my second example, again using the fact that 1 litre is 1,000 millilitres, I can times 1.2 by 1,000 to say that 1.2 litres is the same as 1,200 millilitres. I know that 120 is less than 1,200, so I can say 120 millilitres is less than 1.2 litres. The sixth type of question will either ask you to round to a given number of decimal places or significant figures. In my first two examples, I'm asked to round to a given number of decimal places. Firstly, I'm asked to round 12.8501 to 1 decimal place. Here's my decimal place, so I need to go one value after it, that's the 8, and then chop my value off. I therefore know my answer is going to be 12.8, or it's going to get rounded up to 12.9. To decide which one to take, I need to look at the value to the right of my line and decide whether it's 5 or more. If the answer's no, and it's either a 0, 1, 2, 3 or 4, I keep my answer at 12.8, or like in this case where it's 5 or more, that's 5, 6, 7, 8 or 9, I round my answer up, so I can say to 1 decimal place my answer is 12.9. For my second example, I'm asked to round 4.9832 to 2 decimal places. So again, I find my decimal point, and this time I need to chop it off after my second decimal value, that's after the 8. This time, looking to the right of my line, I can see I've got a number 3, and that is not 5 or more, so I can simply leave my answer as 4.98. I don't need to round it up. I can use a similar idea to help me when rounding to significant figures. In my first example, I'm asked to round 84,950 to 1 significant figure. I need to find my first significant figure, which is 8, chop it off afterwards, and look to the right of that line. As before, if it's 5 or more, I need to round this value up, but because, like in this case, it's not 5 or more, I can keep it as an 8. All of the digits to the right of this line now need to become zeros to keep the place value of the number I had. So to 1 significant figure, my answer is 80,000. In my second example, I'm asked to round 0.000397 to 2 significant figures. In order to do this, I need to find my second significant figure. So my first is going to be the 3, and my second would be the 9. Remember that any zeros at the front of a calculation don't actually add any value to it and therefore aren't considered significant. as before, I need to chop the value off after my second significant figure, and looking to the right I can see I've got a 7. That means that these values need to be rounded up. If I consider this as being 39 and I rounded it up, my number would become 40. I need to make sure everything at the front is added back in, so my answer would be 0.00040. It's really important that you leave the 0 at the end because it asks for 2 significant figures, and my 2 significant figures would be 4 and 0. The 7th type of question will always ask you to work out a percentage of an amount. This percentage will always be a multiple of 5. In order to work this out, we're going to need to work out 5%. So I'm going to start off by saying that 10% is going to be the amount, so 420 divided by 10, and that's 42, and therefore 5% will be half of this, so 42 divided by 2, which is 21. Because I want to work out 35%, I know that I need 7 lots of 5%, because 5 times 7 is 35. That means that 35% is going to be equal to 21 times by 7, and I can work this out using a column multiplication. So 7 times 1 is 7, 7 times 2 is 14, and therefore my answer is 147. I can do the same thing in my second example, so I know that 10% is going to be the amount, 108 divided by 10. That gives me 10.8, and therefore 5% is going to be half of this, so 10.8 divided by 2, which is 5.4. I could do the same thing as before and say that I need 19 lots of 5% to get 95%. However, 95% is just 5% less than the original amount. I can therefore take 108, that's 100%, and subtract 5% from it. So that's 5.4. I can use a column subtraction to help me do this. So firstly, I need to borrow. 10 take away 4 is 6. 7 take away 5 is 2. And therefore my answer is 102.6. Now, because we're talking in terms of money, I need to remember to put a 0 on the end because it's £102.60, and likewise my first answer was £147. The 8th type of question will always ask you to complete an arithmetic sequence. An arithmetic sequence simply means that it's either going up or down by the same amount each time, and we can use this idea to help us find missing values. Because of this, I can say in my first example, to get from 3 to minus 2, I've simply subtracted 5. That means to get from one term to the next, I'm going to have to subtract 5 each time. That also means to get from my original amount to 3, that I took 5 away. So working back forwards, adding 3 back on, would give me my first term, which would be 8. And then again, going from minus 2 and subtracting 5 gives me minus 7. I can check that this value works because minus 7 take away another 5 would give me minus 12, and that's what I wanted. My second question is a little bit more difficult, but I know to get from 1 to 46 that in total I've added 45 on. I also know that I've done this in little stages, so I've added something my first time, added the same amount the second time, and added the same amount a third time. I can use this to help me work out what this missing value is. If I take the whole entire jump, which was 45, and divide it by the 3 little jumps that I know that are the same, I get an answer of 15, which means each time I'm adding 15 onto the sequence to get to 46. So therefore 1 add 15 would take me to 16, that's my first missing term. 16 add 15 would be 31, and checking, I know that 31 add 15 would take me to the 46 that I needed. My ninth type of question will always ask me to estimate a calculation. This does not mean work out the exact answer. Remember, when we estimate an answer, we need to round each part of it to one significant figure. So my first example asked me to estimate 2,497 added to 861. I know to one significant figure that 2,497 would be 2,000, and to one significant figure 861 would get rounded up to 900. So I need to work out 2,000 added to 900. That would give me an estimate of 2,900 as my answer. In my second example, rounding 3,749 to one significant figure would give me 4,000. I need to subtract to that 652 to one significant figure, that would give me 700. And again, if I take 700 away from 4,000, this gives me 3,300 as my estimate. In my final example, I need to round 193 to one significant figure. So that would round up to 200, and I need to times that by 84 to one significant figure. That would round to 80. I know that 2 times 8 would be 16, and adding my zeros on gives me an estimate of 16,000 for my answer. The last type of question will always ask you to convert between mixed numbers and improper fractions. My first example asked me to express 17 over 3 as a mixed number. I know that 17 over 3 simply means 17 divided by 3. If I try and work out how many 3's go into 17, I get 5 whole ones with a remainder of 2. And that means that my answer is 5 whole ones with a remainder of 2/3 left at the end. That's because I was dealing with thirds originally in my question. In my second example, I'm asked to express 2 1/5 as an improper fraction. Because in this example I'm dealing with fifths, I know that each whole one is going to be equal to 5/5. In this particular question I have 2 whole ones, so 2 lots of 5 would be 10/5 in total. I also then have my extra 1/5 at the end. So that means as an improper fraction, 10 add 1 would be 11/5 in total. If you are struggling to complete some of the work from today's lesson, then please do not hesitate to get in touch via comment on Show My Homework. I'll try to make myself as available as possible and get a reply to you as quickly as I can. If the issue requires a little bit more input from myself, I might ask to arrange a time to meet on Teams where I can give you some personalised help with that specific problem.